So far we've described that the standard deviation tells us the average amount by which values in a data set vary about the mean. So as a way to picture this, if we have our mean here, let's just say this is a population, and so our mean is denoted by mu, and then we have values spread across this scale at different points, and maybe we have some clustered over here and maybe a couple here, and we compute a standard deviation, and we find out that maybe sigma says that we have values that are, sigma units away below the mean and sigma units away above the mean on average. In other words, on average, our data points are spread between mu minus sigma and mu plus sigma, right? That's what we mean that it varies about the mean. It means around the mean, on average, most of our, the average spread is sigma units below and sigma units above. However, what about these guys over here? Well, those aren't part of that spread, right? Because this average takes into account the ones that are farther away and the ones that are closer, and basically finds an average amount of spread, if you will. So here's an example of that as well. The values 4, 8, 12, 14, and 12 have a mean of 10, but a standard deviation of 4. So we would say that the average spread is 4. There's our S, because this is missing the dev P for population. We'll say this is for a sample here, and there's our X bar. And if we look at X bar minus S, that would be 6. And X bar plus S equals 14. So we've described the average spread as being 4 around the mean. So the way I want you to think about this is that here's 10, and then 6 is over here, and 14 is up here. And we're saying that on average our spread occurs within 4 units of the mean on either side. Yet we have this value over here, and most of them do, right? Except this value of 4, which is located right over here. That's actually outside of that window. So it's nothing odd has happened here, but we do want to somehow be able to categorize how many standard deviations that value of 4 is from the mean. So we've got this thing called the z-score, and the z-score is simply a value that tells us how many multiples of the standard deviation the value is from the mean. So for instance, if we looked at the value 14 is exactly +1 standard deviations away from the mean. Right? Now the reason I write +1 is because it is above. It is greater than the mean. It is 1 unit above the mean. Now, if we don't have this value, but if we had the value 6, 6 would be -1 standard deviation away from the mean. So the sign is going to indicate whether it's above or below. So this is why I wrote up here plus S and then minus S, and here is our sample mean. Remember, just the distinction between S and sigma is either talking about a sample or population. X bar and mu, again, sample and population. So what about this value of 4? Well, how many multiples? Oh, so by the way, we would say here that z is equal to +1. Here we would say that z is equal to -1. That's how many multiples of the standard deviation those values are away from the mean. Well, 4. If we think about 4, then it's not quite 2 standard deviations away, right? It's 6 units below. So it's 6 units below the mean. And then I want to know how many multiples of 4 is that of my standard deviation. Well, it's -6 over 4. So that value is -1.5. So z equals -1.5 standard deviations below the mean. Okay, so it's if our value was 2, well, if I hypothetically had the value 2 down here, then 2 would be -2 standard deviations away from the mean, right? It's 8 full units. 8 divided by 4 is equal to 2. So this is just a helpful measure when, maybe you're talking about different cities. You can also talk about how many standard deviations values are away from their mean without having to necessarily be talking about the same mean and the same standard deviation. Now, how did we calculate this? Is there a formula for it? Well, yeah, there is, and it could be helpful, but don't get stuck on the formula. The way we calculate this is, well, how far is the value above or below the mean? So take the x value, subtract it from its mean, and then now we have the distance from the mean. So if x is 4 and mu is 10, then 4 minus 10 is negative 6. And then we're dividing it, figuring out how many times the standard deviation, how many multiples of that standard deviation is in that difference. Or if you're talking about a sample, same idea, value minus mean divided by standard deviation. So given a value, now it's really easy to compute how many standard deviations above or below that mean is. So again, we could go back up here for 14. For 14, our z value would be 14 minus the mean divided by the standard deviation, which is 4 over 4, which is positive 1. We can also ask other questions, like a value is 3 standard deviations below its mean, mu equals 34, and sigma equals 4. What is this value? Okay, well, if I know that this value is 3 standard deviations below the mean, that means it's 3 multiples of 4 below the mean, right? One standard deviation would put me at 30, another one would put me at 26, and yet another one would put me at 22. So the value that I'm looking at would be x equals 22. In other words, mu minus 3 times our sigma would be 34 minus 3 multiples of 4, which is again 22. Now you could also get this from the z-score formula. You could say, well, that means that for this particular example, what I'm given is the z value. The z value is negative 3. It's 3 standard deviations below the mean. Negative 3 equals, I don't know what the x is. I know that mu is 34. And I know that sigma is 4. And so if I multiply both sides, if I solve this equation, I multiply by 4, negative 3 times 4 equals x minus 34. And now if I add 34 to both sides, I get x equals 34 minus 3 times 4. And check it out, same computation we did up here. Didn't really require a formula. You don't have to memorize this formula as long as you understand the concept of the z-score is just how many multiples of the standard deviation a value is away from its mean.